Find the area, centroid, inertia, and volume of the parabola, which is y is equal to x squared, and the horizontal line, which is y is equal to 4.
Let's continue with our region bounded by y is equal to 4 and y is equal to x squared. From x is equal to negative 2 to x is equal to 2. And find the area moment of inertia, also known as the second moment of area. So our goal is to find the moment of inertia of the shaded area with respect to our x-axis, and the second one is the y-axis. So the formula which we are going to use, which is this 1/3 AB close bracket open bracket f of x squared minus g of x squared close bracket dx for our inertia in y. So limit AB x squared open bracket x minus g of x close bracket dx. So this formula, so for our x-axis, so this formula is used to find the inertia for horizontal axis. So however, for the moment of inertia for our problem, so if a composite shape with respect to x-axis or no centroid adjustment, the correct form is, so our correct formula rather for this is equal to Ix is equal to the integral of limits AB f of x squared minus g of x squared dx. Then substitute the value of all the given. So our a is negative 2, f of x, which is 4, squared our g of x, which is equal to x squared dx. Next, so for 4 squared, what's the answer for that? Is 16, right? And so we forget this to put squared. So x squared raised to 2, which can give us the answer of x raised to 4. And now let's integrate this. So negative 2 and the positive 2 limit. So the integral of 16 will become now 16x minus, so our x raised to 4, let's add 1 or use the power rule, which this will become now x raised to 5 over 5 dx. So next, let's substitute the value of limit. So 16 multiplied by 2 raised to 5 over 5 minus the value of substitute the value of a limit, which is 16 multiplied by negative 2, so negative 2 raised to 5 over 5. So if we're going to plug this in calculator, it gives us the answer of 64, and this one give us the answer of 64 over 5. Then we have to subtract it, so this give us the answer of 256 over 5, or in decimal this is equal to 51 8.2 units. So next we have to find the IY. So find IY. So what is the formula for finding the in y-axis or inertia in y-axis? So it is the integral of AB x squared bracket f of x minus g of x dx. So let's see if this is correct. Oh, that's correct. And substitute the value as usual. So negative 2 x squared, the value of f of x, which is 4, minus the g of x, which is x squared dx. Then substitute this or multiply it term by term, which it give us, so x squared multiplied by 4, this is around 4x squared minus x squared multiplied by negative x squared, negative x raised to 4. And now let's integrate this. So 4x squared will become now 4x raised to 3 over 3, right? So the x raised to 4 will become now x raised to 5 over 5 dx, right? Next, substitute the value of limit, which is iy 4x multiplied by 2 raised to 3 over 3 minus 2 raised to 5 over 5 minus by the limit of a, which is the negative 2, 4 multiplied by negative 2 raised to 3 over 3 minus negative 2 raised to 5 over 5. And now if we are going to plug this in calculator, this can give us the answer. So if this plug in calculator, so it is equal to 64 over 3 minus, so this one I plug in calculator, it is equal to 64 over 5, which is, it is equal to 128 over 15, or in decimal it is 8.533 units, or 4 units raised to 4. So this is our answer in inertia in y-axis, and this is in inertia in x-axis. So that's all. Let's now solve the volume of the solid formed when the region between the curves y is equal to 4, which is, this is our top line, and y is equal to x squared is our bottom parabola. So we have to use the desk method to find the volume of the solid of revolution. So we know that if the region is revolved around the x-axis, in the x-axis, and bounded above by f of x and below by g of x, so our formula for that will be volume is equal to pi integral of AB, so f of x squared minus g of x squared dx. So let's plug in into the formula. So as the same, our limit is also the a is equal to negative 2, b is 2. So volume is equal to pi, our a is negative 2, and our f of x, which is 4 raised to 2, minus our g of x, which is x squared raised to 2 dx. And now let's integrate this. So pi limits of negative 2 and positive 2. So 4 is equal to 16. So the integral for 16 will become now 16x minus x squared raised to 2. So multiply the power, which become x raised to 4. But the integral of x raised to 4, so we have to use the power rule. It will become now x raised to 5 over 5 dx. And then but first, let's have I have to show you why we use disk method. So we know that if we revolve around the x-axis, this can give us revolve right here. So there is a hole, right? So here, so the drawing will become now like this. So there is a hole. From here, the distance here from here is, this is the f of x, and the distance between here to here is, this is the g of x. That's why we formed this formula. So then let's continue this. Substitute the value of limits for this. So now volume is equal to pi multiplied by 16, 2 minus 2 raised to 5 over 5, minus, let's substitute the limit of a, which is 16. Wait, this is very ugly. So 16 multiplied by negative 2 minus negative 2 raised to 5 over 5. Let's now use calculator for solving this. So in this part, if we are going to solve this in calculator, this can give us 64, right? And this one can give us the answer of 64 over 5, which is, this also can give us the answer of, so pi multiplied by 256 over 5, or equal to 256 pi over 5 cubic units. So this will be now our